Proof number 67. Prove that nPr is equal to n-1 Pr plus r into n-1 P r-1, where small n and small r are positive integers, and n-1 is always greater than or equal to r. N and r are positive integers and n-1 greater than or equal to r. So transpose -1, n greater than or equal to r plus 1. Okay, my n value must satisfy this condition. Okay. So anyhow, here we have to prove LHS equals to RHS. nPr is equal to n-1 Pr plus r into n-1 Pr-1. This is one of the important formulas in permutations and combinations. So to prove this formula, I am going to consider RHS. Why RHS? Why not LHS? Enduku RHS తీసుకోవాలి? Because of course we can consider LHS also, but solving this problem using RHS is very easy. Okay, it will take less number of steps. So that's why I'm going to consider RHS. Here RHS is equals to what? Right hand side expression. RHS is equals to n-1 Pr plus r into n-1 Pr-1. Okay. So we are going to prove RHS equals to LHS. So this is RHS and this is LHS. So what is our final answer? Here our final answer must be nPr. We have to prove RHS equals to LHS. So this is LHS, left hand side expression, and this is RHS. Okay. First of all, here n-1 Pr. This is like nPr. So what is the formula for nPr? nPr. So actually we should take small letters, but to avoid confusion, I'm considering small capital letters nPr. So nPr formula n factorial by n factorial by n minus r factorial. N factorial by n minus r factorial. Here n is equal to what? N minus 1. N is equal to n minus 1. Capital R is equal to small r. Now n minus 1 Pr is equal to n factorial, means n minus 1 factorial by n minus r factorial. N means n minus 1 minus r. R means how much here? Small r. Small r factorial plus r into again n minus 1 Pr minus 1. Here what is the value of capital N? N minus 1. What is the value of capital R? R minus 1. Okay, use same formula. nPr is equal to n factorial n minus r factorial. N minus 1 Pr minus 1 equal to n. So n factorial n minus 1 factorial by n minus r factorial. Here n is equal to n minus 1. n minus 1 minus r whole factorial. What is r here? R minus 1. So keep open brackets. R minus 1 whole factorial. Okay. N factorial n minus 1 factorial. Here n is equal to n minus 1. R is equal to r minus 1. N equal to n minus 1. N minus 1 factorial by n is equal to n minus 1. Minus minus. What is r here? R is equal to r minus 1. Here value of r is binomial. So we should keep open brackets. Okay. This minus is distributed to plus r and minus 1. Okay. Next, n minus 1 factorial by n minus 1 minus r factorial plus r into n minus 1 factorial divided by n minus 1 minus into plus minus, so minus r minus into minus plus, plus 1 factor, plus 1 factor. So minus 1 plus 1 get cancelled. Now next step, n minus in first term and second term, n minus 1 factorial, n minus 1 factorial common. Take out n minus 1 factorial. So n minus 1 factorial into 1 by n minus 1 minus r factorial plus r by n minus r factorial, n minus r factorial. Next, n minus 1 factorial into here we have 1 by n minus 1 minus r factorial. Here denominator is n minus r minus 1 factorial. Here denominator is n minus r factorial. To make common denominators, or to make common denominator as n minus r factorial, here multiply first term. So first term means 1 by n minus 1 minus r factorial. So e term ni multiply this term and divide, multiply and divide this term by n minus r. So it means say 1 by n minus r minus 1 factorial, multiply and divide this 1 by n minus 1 minus r factorial by n minus r, n minus r by n minus r, multiply and divide by n minus r, okay, plus, right, remaining term as is r by n minus r factorial, okay. So now we can make common denominator as n minus r factorial. Why? How? Say, here denominator is n minus r and here denominator is n minus r minus 1 factorial. So we know that n factorial is equal to n into n minus 1 factorial, n into n minus 1 factorial. Similarly, suppose n minus r factorial is there. So we can write n minus r factorial as n minus r into subtract 1 from r. Okay. So okay. N minus r minus 1 factorial. Keep factorial. If n factorial is equal to n into n minus 1 factorial, then n minus r factorial is equal to what? N minus r into n minus r minus 1 factorial. Just observe denominator. N minus r into n minus r minus 1 factorial. So in place of this denominator we can write n minus r factorial. Now n minus 1 factorial into 1 by n minus 1 into n minus r, n minus r by, instead of n minus r minus 1 into factorial into n minus r, we can write n minus r factorial plus r by n minus r factorial. So now denominators are same. Now denominators are common. Okay, na? Write common denominator and add numerators. Write common denominator n minus r factorial. Add numerators n minus r plus r. Minus r plus r get cancelled. So n into n minus 1 factorial by n minus r factorial. Okay. Again n into n minus 1 factorial is equal to what? N into n minus 1 factorial is equal to n factorial. N into n minus 1 factorial equal to n factorial. Here we can write n factorial by n minus r factorial. So n factorial n minus r factorial is equal to formula nPr. This is LHS. Okay, na? So since LHS equals to RHS, hence proved. Okay. Therefore, nPr is equal to n minus 1 Pr plus r into n minus 1 Pr minus 1.